Hi everybody. In this video, I'm going to go through our examples for the other quadrilaterals and their properties video, or lesson, excuse me. So this is talking about trapezoids and kites, and this does have an image with it. So please head to the course and either print this image out or take a moment to use a straight edge and your pencil to recreate it. I would just draw a coordinate plane, kind of label my axes, do like maybe 5 both ways, and then create your 4 points that you can then connect. But the main thing here is identifying those 4 points because we want to show ABCD is an isosceles trapezoid, which thinking about what that means, I know that in a trapezoid, we have one set of parallel sides, only one. And then if this is an isosceles trapezoid, that means then that the legs are congruent. So if I want to show that this is an isosceles trapezoid, we need to show, first of all, that this is a trapezoid and I only have one set of parallel sides, and then I need to show those legs are congruent. All right, so what are these points? Let's go ahead and just label them all real quick. So I have A, which is the point, looks like -5, -1. I have B, which is the point -2, 3. I have the point C, which is 1, 3. And then I have the point D, which is 4, -1. Now, the first thing I need to do again is show that this is a trapezoid. Is A, B, C, D, a trapezoid? So we're going to look for one set of parallel slopes. So we need to find the slopes of the 4 side lengths, and please just make a little note here. Your slope, oops. You can always use the slope formula. So you can use that, oops. y2 minus y1 over x2 minus x1, or I mean, you can always count visually and find your rise over your run. Whatever method works for you here, but we need to find the slope of all 4 sides. And yes, all 4, because we need to show that not only are, one set parallel, we need to show the other set's not. So let's find first the length of segment AB, the segment from A to B. So slope of AB. And I'm going to do this visually here. So I'm going to find my rise over my run and start at your left point. So starting at A, I have to rise up 1, 2, 3, 4 units. So my rise is 4. And my run from here, I will have to go over 1, 2, 3. So this is our slope, 4/3. Now let's find our next side, BC. And this is a flat line. I hope you remember what the slope of a flat line is, excuse me. Counting your rise over your run, or even using your slope formula, we will not have any rise, right? I don't have to go up or down at all to get from B to C. So this has a rise of 0 and a run of 1, 2, 3. And that simplifies, of course, to just 0. All right. Now, next, we need to find the slope of CD, and I'm not expecting this to be parallel to anything, but I still need to find it, so I'm going to find that over here. Slope of CD. And again, start at your left point, C, and I'm going to use my rise over run formula for slope, and from C, I have to go down 1, 2, 3, 4 units. So this then is a rise of -4. And our run from here would be 1, 2, 3. So this has a slope of 4/3, which is not parallel, right? That's not parallel to positive 4/3. It's not parallel to 0. And let's now find our last slope, AD. And AD is another flat line, right? I notice I'm not going to have to rise up or down anything. So my rise would be 0 over this run is 1, 2, 3, 4, 5, 6, 7, 8, 9. So please notice that these two slopes are equal. So I could say the slope of BC equals the slope of AD. And therefore, these two lines then, BC and AD, are parallel. Why is that important again? Well, we know that CD and AB are not parallel, but these two are. So we have one set of parallel sides. So ABCD is a trapezoid. Because we have this one set of parallel sides, BC and AD. Now I just need to show, is it isosceles? Are those two legs congruent? And we now know, right? We now know that BC and AD, those two are parallel, which means these two are the bases, right? So the bases are BC and AD. So our legs are AB and CD. So let's find the length of AB. And I'm also going to need then the length of CD, the other side. And please, 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 please use your distance formula for this. Write it down. Let's see, what color do I want to use? Maybe light blue. Our distance is always the square root of your difference in y values, y2 minus y1 squared, plus your difference in x values, x2 minus x1 squared. And we already have our points, right? A is 5, -5, -1, and B is -2, 3. Oops, so I'm going to grab those 2 points and just put them down here so I can label them. A will be my x1, y1, and B will be my x2, y2. Oops. And now I can substitute these values into our formula. So we're going to have this square root with these two sets of parentheses being squared. And they are added, right? So it's two sets of parentheses. Both sets are being squared, plus sign in between the two of them. And then inside, you have these differences. So we'll start by subtracting our y values. So I'm going to subtract y2 minus y1, which is 3 minus -1. Now that's kind of awkward looking. And then we're going to subtract our x values. So x2 minus x1, which would be -2 minus -5. Now, I really encourage you to simplify this part in your head. It looks scary, but imagine and know that those two negatives in a row are pluses, right? So these are plus signs. So this is really the square root of 3 plus 1 squared, or 4 squared, plus -2 plus 5 squared, which -2 plus 5 is +3 squared. -2 plus +5 is 3 squared. And now we can simplify even a little bit more. 4 squared is 16 plus sorry, why do I keep thinking it's negative? 3 squared is 9. So the square root of 16 plus 9 16 plus 9 is 25. So this is the square root of 25, which is 5. So that is our length of segment AB. It's 5 units. We also need to find the length of CD, right? And CD involves points C and D. So I'm going to grab those. C is 1, 3, and D is 4, -1. And we're going to use those to find the length of CD. So labeling these again, C can be my x1, y1, and D can be my x2, y2. And this is going to be the square root of a set of parentheses squared added on to another set of parentheses squared. And then inside those parentheses, we are subtracting. And I will start by subtracting my y values. You could start with your x values if you wanted to. So y2 minus y1 is -1 minus 3. Plus, now subtracting my x values, I will subtract x2 minus x1, or 4 minus 1. And then I can simplify a little bit. -1 minus 3 is going to be -4 squared, plus 4 minus 1 gives us 3 squared. And notice those numbers are kind of similar to what we had up above for AB, right? And now simplifying just a little bit more, -4 squared, that's -4 times -4, which is 16, plus 3 squared is 9. So this is still the square root of 16 plus 9, which is the square root of 25, which is 5. So CD and AB are both 5. So this shows here that AB is equal to CD, which means then that those two segments are congruent. So this is an isosceles trapezoid. A, B, C, D is an isosceles trapezoid because those two legs are congruent. All right, example 2. That was the longest one, I promise. In kite JKLM, MJ is equal to JK, KL is equal to LM, and diagonals oh, I messed that up. There's supposed to be a period after the JK, or sorry, KL equals LM. So we know we have these two sets of congruent sides, which makes sense since it's a kite. And then we know, sorry, my apologies, the diagonals JL and KM intersect at P. That's a point, so they intersect at point P. So that Km is equal to 40 and PL is equal to 48. And this problem actually does not come with an image, but we can draw one. So we need to draw a picture here for this problem, and it's a kite. So I'm going to draw a kite as I know what a kite looks like with those two sets of congruent adjacent sides. And this kite's going to look a little bit rough because I'm using the auto fit for the bottom two. So using what I know, MJ is equal to JK. And these are adjacent sides, so they should share the same vertex, right? One of those angles is the same. And it looks like they both meet, right? MJ and JK both have this J in common. So I'm going to take two of my segments that share the same two of my congruent segments that share the same angle, and that shared angle will be J. So this can be point J. And then the other angle that is shared by the two opposite congruent sides, we have KL is equal to LM. So those meet at point L, right? So this opposite side where the two congruent sides meet, that can be point L. And now I can kind of just fill in the rest of the pieces, right? I know that MJ is equal to JK. So these are congruent. And then KL is congruent to LM. So it works out. Diagonals, JL, here's JL, and KM or MK meet or intersect at point P. We know that KM, so let's identify where KM is. That is this diagonal, and that is 40 units, and PL is 48. So that is from P down to L. So to tackle this problem, I know that I have this entire yellow length, which is 40 units, and then I have this part of a diagonal that is 48. I need to figure out what, and I never wrote down the goal of this problem. What is ML? So we want to find the measure of ML. So we want to find this side, this length from M to L. And to do this, please remember that our diagonals of kites are perpendicular. Kites are perpendicular, which means then that all of these angles are right angles. Especially, the angle I'm going to care about especially is the measure of angle MPL. That is 90 degrees. Why do I care about that? Because that forms a triangle, right? I have this triangle, MPL, and I know that one of the angles is a right angle. So this is M, this is P, this is L, and this here is 90 degrees. It's a right angle, so this is a right triangle, and I could use the Pythagorean theorem. To find this hypotenuse ML, because MP, this is like one of my legs, my A, PL, that's like my B, and then ML, that's the hypotenuse, my C, and the Pythagorean theorem says that A squared plus B squared is equal to C squared. Okay, great, that's the vision. I know that PL is 48, right? So PL is equal to 48. I don't know what MP is though. And I do know that KM, right, the entire diagonal KM is 40 degrees. So the other thing I need to remember is that one of these diagonals is the perpendicular bisector of the other. And so here, actually, PM and PK, those are congruent halves. So MP, that is equal to 1/2 of KM. It's half of it. I know that's the one that's being bisected because look at the other diagonal. The other diagonal, JP and PL, that makes up JL, those two halves are not congruent, right? And then of course the opposite angles here are the ones where the non-congruent sides meet up. So that would be at M and K. So the diagonal going across those angles is the one that is being bisected. This takes practice as well. So if you're feeling super lost and confused, please just follow along and then spend some time in the OMHS practicing. And we know that km is 40, so MP then is half of that, or 20. So MP is 20 and PL is 48. Our goal is to find ML. So essentially here, I'm going to take PL squared and I'm going to add that on to MP squared. And that's going to give me ML squared. And we know PL is 48. So 48 squared plus MP, which is 20 squared, is going to give us ML squared. 48 squared, if you type that into your calculator, you actually get 2,304. And then 20 squared is 400. 20 times 20 is 400. And if you add those together, you're going to get 2,704 is equal to ML squared. So what is ML? Let's take the square root of both sides. And if you take the square root of that, it looks like a crazy number, but you actually get that ML is 52. It's crazy. But 52 times 52 gives me 2,704. I want to do one more. One more example. You're hanging in there. I appreciate you. This one I hope will be the quickest yet. EF, segment EF, is the mid-segment of trapezoid ABCD. AB, sorry, that A looks a little bit rough. AB is equal to 5x plus 12. EF is equal to 5x. And CD is equal to 3x. What is x? Solve for x. And then we have our diagram here. You actually, could create our own diagram for this, but there was one given. And oops, I should have tried to do it this way. My apologies, because that would take way longer. Oh, here's my trapezoid, kind of. I don't love it, but pretend it's a trapezoid. I can't live with it. Oh my gosh. Okay. 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 There's our trapezoid. A, B, C, D, and it actually is A, B like this, and then C, D like this. And then we have mid segment E, F. Okay. Sorry for the hassle with that drawing there. So AB is 5x plus 12. I don't know why I changed the color of that. So this side here is 5x plus 12, and notice that this is one of our bases, right? And EF, that is our mid segment, that is 5x. And then CD is the other base, and that is 3x. So if we're going to solve for x here, I actually need to remember that the mid segment of a trapezoid, so trapezoid mid segment, is equal to the base 1 plus base 2 all divided by 2. Which seems really weird, but our mid segment here is EF. So that is equal to are two bases, so AB plus CD divided by 2. So we can substitute in what we know. We also, might not like this fraction, so I could multiply 2 to both sides. So now I know that 2 times EF, or 2 times 5x, is equal to AB plus CD. And AB is 5x plus 12, and CD is 3x. So 2 times EF, 2 times our midsegment, is equal to the two bases added together, AB plus CD. It's kind of the important thought at play here. And now I can simply solve. So 2 times 5x is 10x, and that will be equal to, over here on the right side, 5x and 3x combines to give us 8x plus 12. And then I can solve for x further. I would need to subtract 8x from both sides. So I get 2x is equal to 12. And then I can simply divide both sides by 2 to get that x is 6. So it seemed kind of crazy at first, but we can really pull it all together. Thank you for hanging in there with this lesson and with this unit. It has a lot to it. Please let me know what questions you have.